right, so when we do these problems, our first step is we've got to get a total population. So when I add up the populations of the 8 groups, I get 3,225. And then I need to take that 3,225 and divide it by 60. And when I divide that by 60, I get 53.75. Okay, so there's our total population, and there's our standard divisor. And I'm going to take that 53.75, and I'm going to divide it to each population. Now, the first one, I believe, goes 5.079. So it's 5.08. We have to round correctly. Make sure you go to that third number after the decimal point to help you with your rounding. B should be 7.93. Don't be at 7.92 when you should be at 7.93. C is 6.98. D is 3.65. And I'm getting all of these by dividing the group's population by the standard divisor, which is 53.75. So essentially this number is 701 divided by 53.75. So this becomes 13.04. This becomes 6.34. 89 divided by the 53.75 is 1.66. And then 824 divided by the 53.75 is 15.33. And that's how we get our standard quota. We're going to do that at the beginning of every single problem, regardless of Hamilton, Jefferson, or Webster method. Total population divided by the amount of reps to get your standard divisor, and then you take each individual group's population and divide it by the standard divisor. Now my lower quota I can do very quickly. It's literally the number in front of the decimal point. You're rounding down no matter what. All right, 4.99 would round down to 4. 4.00 rounds down to 4. Whatever the number in front of the decimal point is, that's our lower quota. Our upper quota, we just add 1 to the lower quota. So no matter what the upper quota is, you add 1 to it. Or no matter what the lower quota is, you add 1 to it to get your upper quota. And when I add these up, they should be 8 apart. There's 8 groups, so they should be 8 apart. When I add up that lower quota column, I get 56. When I add up the upper quota column, I get 64. Now with Hamilton method, I copy down the lower quota in my initial apportionment. So everyone gets at a minimum their lower quota. Everyone at a minimum gets their lower quota. Okay. And now I need to give away the votes. Now, everyone has at minimum their initial apportionment, which is the lower quota. That was 56 votes. Okay. At 56, I have 4 votes to give away. Okay, and it's the 4 highest numbers after the decimal point. 0.98, 0.93, 0.66, and 0.65. Okay, and then for my final apportionment, 5, 8, 7, 4, 13, 6, 2, and 15. If I add 1, I put it in the final apportionment. If I don't add 1, I just keep that same number. All right, so with the Jefferson method, we get our total population, we get our standard divisor. We take that standard divisor and divide all 8 individual populations to get our standard quota. And now we take our lower quota just like Hamilton. 7, 11, 12, 9, 3, 14, 10, and 6. And we're going to add that up. Okay. And that lower quota is going to be what? Was it 72? Very good. Okay. So in this case, we have 72 of our lower quota. Okay. We need to find 3 groups to move up a representative. biggest populations and populations closest to the next number. I think this one is pretty obvious that B, C, and F are going to be the three that move, and I think F is going to be the last one to move. So my modified standard divisor is going to be 906 divided by 15, because I want to get this one to the next number. When I do 906 divided by 15, I get 60.4. And that, I think, is going to be my modified standard divisor. When I divide all of these by 60.4, I'm going to get numbers that should work out. Now, my numbers may not be exactly right. The number I put in, okay, was a little bit different because you have a range of answers you can use. But at 60.4, we would get something like 7.54. And my lower quota is 7. 11.6 would move up. Let's say 12.10. And that stays at 12. 809 would move up. You'd probably go to like 13.45. And that's 13. The 9 does not move up. We'll go with 9.82. We'll say 9, 3.61. 14.36 is 15.00, which is 15. And this is done by taking all your populations and dividing by that new modified standard divisor. Once again, these may not be perfect numbers, but they'll make the point. And then we'll say 6.35, and that gets us to 50 with 3 votes being increased. Okay, so now we gave 3 votes or 3 reps away to B, C, and F. All right, so my initial apportionment, 3.83 becomes 4. 4.84 becomes 5. 1.96 becomes 2. 9.23 becomes 9. 13.8 becomes 14. 3.52 becomes 4. 6.86 becomes 7. And 10.97 becomes 11. And when you add all of those up, you get 56. And we need 55. So the most likely candidate to move, and now we need to move it down. So my standard, modified standard divisor is actually going to move up. This is probably the most likely candidate to move down. Because even though it's a smaller population and move a little slower, it's so close to where it needs to get to. We need to get that 3.52 to a 3.49 to move it down. Remember, when you're moving numbers in Webster, 0.5 is the key number. So 251 divided by 3.49, which is the standard divisor I'm going to now want, is what? What do you got, Mary? 71.91. Very good. Okay. Now, it basically moves everything a little bit down. 3.81 stays 4. 4.82 stays 5. 1.95 stays 2. 9.21 stays 9. 13.8 might come down to like 13.76, but it's still going to stay with 14. This is a 3.49, so it stays 3. 6.84 is 7. And 10.97 is like 10.95. And we'll keep that at 11. And that gets me at 55. And that is the... All right, on this one, we're going to round normally. Once again, that stays 11. That stays 9. This comes up to 3. This goes up to 18. This stays at 3. This stays at 5. This stays at 13. And this stays at 17. And I would argue this one's also pretty obvious in terms of what's going to go up. And that the H is the closest to 0.5. And it's the biggest population. So we're at 79. We need to get to 1 vote. I need to get this to 17.50. Okay? So I'm going to do 920 divided by 17.5. Can someone tell me what that number is? 920 divided by 17. Go ahead, Marion. The Marion's at 52.57, which I agree with. So that's going to be my new standard divisor, my modified standard divisor, 52.57. And you notice they don't move very far. Okay? When I put these in, this will make this 11.22. Stays at 11. This will make this 9.17. This will stay at 9. 2.56 might go to 2.58. That stays at 3. This might go to 17.81, but it's going to stay at 18. 3.39 might go to 3.41, it'll stay at 3. 5.25, it'll stay at 5. But then 13.7 might go to 13.31, but it's going to stay at 13. And then finally 17.44 goes to 17.5, and this rounds up to 18. We have 4x times 2x, 8x squared. 4x times 5, 20x. Negative 3 times 2 minus 6x. Negative 3 times 5, negative 15. 8x squared plus 14x minus 15. 5x times 3x is 15x squared. 5x times 8 is 40x. 4 times 3 is the 12x. 4 times 8 is 32. And we combine the middle term. You have to make sure 5x times 3x is 15x squared. The common mistake is people write 15x and combine all three. You can't do that. It's 15x squared. We're combining those middle terms. And that's my answer. 3x times 4x, 12x squared. Oops. 3x times negative 7 minus 21x. Negative 2 times 4, negative 8x. Negative 2 times negative 7 plus 14. 12x squared minus 29x plus 14. 6x times 3x is 18x squared. 6x times negative 7 minus 42x. 11 times 3x is 33x. 11 times negative 7, negative 77. 18x squared minus 9x minus 77. And that is our